Webinar today. I was talking with Lisa and a few guys from SCS a few weeks ago about potential topics, and as we do custom, individual, and open source and sovereign AI for 1.5 years now, it was a good topic to choose. And that's what we're doing today. So, as I said, today we're talking about how our journey as artcodix was, and where did we start, and how did we get along all these topics. We will go over some struggles and takeaways of those, what we're doing right now, and actually how we do it, like a technical overview. And yeah, for sure, we have a live demo in the end, if anyone is interested, and a Q&A session as well, as Lisa already mentioned. So we can start with the perfect thing here, our starting point. Our starting point was that we were already doing now 2.5 years of being like a SCS cloud provider, by now also certified, thankfully, in the last SCS summit. But we got a few takeaways from this journey, that the cloud market is actually really a fierce competition, because you always have discussions, either most of the customers already have some cloud providers and whatnot, so you have to be at some point getting at the right moment into the customer or to the customer when he's having problems with their clouds. So it's a very harsh business to actually get along as a small regional company. So what we did in the last 2.5 years was that we tried to expand on top of the SCS platform and try to add values for the customers. And we did that pretty successful in different niches and different branches, with a lot of customers. But the whole AI journey started when one of the customers asked us if we could build a prototype for them for hosting their own ChatGPT, if you wish. And that was in the end, it was the starting point for our journey in that regards, and that started all the investigation, development, and all the other things we will dive into in a few later slides. What the AI prototype actually is doing today, we developed a lot of additional features for the customers. Sorry? Okay, I had an interference here. We developed a lot of additional features on top of the AI, like classic chat, to have a pretty competitive solution, which our customers actually need, or like every customer needs, if he really wants to use AI in his company, in their company, without having the dependency on the big ones, as we all know, like Anthropic, Google, and OpenAI and whatnot. And a lot of time went into such adjustments and fine-tuning of the models, of the workflow, of the pipelines. And in the end, the whole thing, what we learned to do is that we have to create our own ecosystem, which sounds, when I say it now, a little bit not really open, but it's indeed exactly that. We try to build an open ecosystem where everybody in the end can use it with default frameworks and everything the market already knows and all the developers already know. So we try to lean on that what is already there, and try to build on top of that, and add more values on that. And the current status, as I wrote it on the slide, is we are growing alongside our prototype, which is actually a good thing for us, but it's sometimes a little bit challenging. Talking about challenging, the first thing as a cloud provider who tries to go into the AI is that we always have a few challenges. And I guess you guys have those as well if you dive into that topic. The main part is that data security is like the most crucial concern, at least you think that it is. In the end, there are many other reasons customers will decide, and data security is for most of them, at least 1 year in the past, not the biggest one. Most of them is like money or ease of use in some other cases. But I wrote in the last point, like the geopolitics and all the stuff which happened over the last 1.5 years, made it a little bit easier because people actually now think about sovereignty, which we also see in the SCS context, especially, but also in this part, because it's like kind of the same niche where we dive into. And the biggest problems with the big providers as of right now are that there is like potentially sovereignty, which they actually say that they have, or they claim at least that they have GDPR compliance. But in the end, there is no data sovereignty at all, if you really think about it, because there are some things like the Cloud Act we all know, and the FISA 702, which is the Foreign Intelligence Surveillance Act. They always will come in the end and have the potential to get the data because it's an US company. When we talk about Microsoft, Google, OpenAI, and whatnot. And those things mean not much to everybody, but it gets more in our opinion. And we have like really good discussions with a lot of customers, even big ones, where the mindset changes on those topics because they kind of understand that there is a thing we have to do as European guys, and we have to just think about it and get the idea where to put data, especially when companies want to use AI really efficient inside their company with like internal data or like special security needs data, where like even the pretty open guys, which they like Microsoft and Azure and whatnot, they don't really want to put those data to the US companies. So that's the real parts on it, and the real challenges that you have to like come through those ideas from the customer that they actually don't really need like a regional partner or like a European partner, because they have like the OpenAI stuff and so. But we have like solutions for that. We have ideas for that, which works, or which worked, and I want to share those, because our mission, and I guess that's most of your mission as well, is that we want to have solutions that can kind of compete with the big players in the market. Like, to be honest, we can't really compete with them on like every layer, but we can try to get like feature parity and some other things. And the main thing we actually deliver and try to deliver is like high quality and to an affordable price, which our partners and customers can actually pay, and which we can offer without like being forced to pay on top of that. Because in the AI market, and I will come to that in a later stage, the biggest thing there is like the investment you have to take. And not only the initial investments, but like the GPUs and stuff, also like the power consumption and every other thing. But in the end, if calculated right, there is a business case even for smaller ones. And I can tell you a little bit more about that. Our focus is or like our USPs, if you want, and that's based on the SCS environment. is that we deliver like high data security and especially like governance and compliance, which we can deliver as a German company inside Germany for our regional partners. And the special thing is that in comparison to the big ones, we actually can make completely custom solutions tailored to any company's needs. Because we don't have to, or we aren't forced to make solutions which suits like thousands or millions of people. We can invest our time in making like a better solution for every individual customer, which is a special case, to be honest, because it changes a lot of how you work and how you design things in the architecture. Our customers, like we have actually only one or two customers which have like general purpose access, and most of the others do have some kind of special needs. And especially like the transparency and the data journey are things which are a special part for us as well, because we partner up with an ISP, or actually like two ISPs by now, where we can offer direct dark fiber connections to the data center and to the AI machines or AI nodes to the inside our AI cluster. And yeah, for sure, personal support in the end is a big part of that as well. Because if you give them like a personal contact information or a direct line to you, that's like a big difference for many decision makers. Because they are not just a number or a random guy. They're like a actual customer and a well-known person. Yeah, coming over, like not every journey is working perfectly all the time, as we all know. So we had a lot of struggles, and perhaps you are having struggles as well right now doing such a journey, and perhaps my takeaways or our struggles can help you not doing them or make your decision a little bit easier. First things first, the hardware selection. Like what kind of hardware do you actually use? There are so many different types of GPUs, like at least two big vendors, which are potentially usable. And then comes like all the other stuff, like power supplies, the rig itself, what racks do you use, and how do you cool all that stuff. So that was actually one of the biggest troubles and struggles early on, because with not really big experience in that part, it was a lot of try and error to get like the right way which works for us. Because like we aren't OpenAI or some other big company which can just like throw a few hundred thousands or millions of euros or dollars inside such a project. We have to like pay it from our cash flow. So it was a big thing to actually think smart about how do we do the hardware selection, and how do we actually build all this stuff. Yeah, like I said, the big upfront investments were one of the struggles, but also like the ongoing costs of the AI machines, because you somehow have to make the calculations and put it onto the price for the customer, and then you are in a problem because you like somehow have to compete with the very cheap prices from the big providers, and yeah. You have to do like a big calculation left and right here to actually find a good price which works for you and works for the customer as well. Yeah, one of the biggest struggles was the GPU market itself, because it's dominated by all these scalpers, miners, and like big AI companies, as we see as of right now. Again, all the hardware market is kind of on the peak, or not even on the peak, as some people say. It's getting worse. So the investment will even gets way worse in the next month, as it is already. and that's always like a struggle. So we have to like buy smarts and buy a little bit on upfront and keep it so we can actually expand when the customer needs it, and don't have to have the trouble always. So a good hardware pipeline is also a big part of all this. Talking about the 24/7 usage, which comes from that we decided early on that we want to try if we can make all this happen with non-data center GPUs. So we are using, or we started using, in the start with consumer GPUs. So we had like two big options. So one was like the NVIDIA, and one was the AMD. We actually tested both pretty successfully. We started with like NVIDIA 4090s and like 5090s over the past like 6 to 8 months, and also some AMD graphics with the XTX 7900. And then one of the struggles was that we actually don't know how these GPUs work in a 24/7 environment over like 6 months, 12 months, 18 months. So that also comes to the big problem. How do you actually make calculations out of this to not like pay on top of this and you actually earn money? So we had some testing environments and tried to replicate like load on those, and did like a lot of testing, but most of it was in the end until now, doing it like for like 1.5 years is try and error, and we just try and make the calculations right. One of the struggles was also that we early on, like we were discussing with many other partners and other players in the market about the GPU considerations. When we're talking about consumer GPUs, like everybody said, okay, their AMD is just not an option. You have to go with NVIDIA. But from a price perspective, it was pretty clear that if we can make AMD GPUs work, it's a big benefit for us, because we can, like at that point back in time, we could buy two like flagship GPUs from AMD for the price from one NVIDIA card. And we were pretty sure that we get more performance out of it than just 50% of one NVIDIA card. And so we invested a lot of time into making AMD work with our framework, and invested here and into the open source community, which work on like drivers and other stuff for this model serving. Because with like Olama and VLLM and all the stuff, like AMD was not really well supported, but AMD itself pushed a lot of their know-how and power into making some better drivers for it, because the most performance degradation was actually the driver integration for Linux to the AMD graphics. So I will take the takeaway for this up front. That's the market was kind of right. So AMD is not really good and not really a good solution, but it's a solution for some niches. So AMD definitely has their place in the AI sector, especially for some kind of models, for classic inference models. the AMD consumer cards work really, really good, especially if you take the price in consideration. But the overall support and compatibility to NVIDIA is just it's just way better, and you just can't deny it. The lack of the standardization in the non-data center GPUs was also, or is also, a big issue, because, like I said, the driver compatibility to like newer cards, older cards, it depends on the models as well. So not every model works well with every GPU. There are some interactions which make or break the performance. So a lot of work and troubleshooting went into that, and we actually developed, which is not yet open source, but we will try to make it open source over the next like 3 to 6 months, a big testing suite to actually objectively measure not only performance, which there are many suites out there, but also quality of a model in like how do you say it? Like in big numbers. So we test like a few thousand queries for every model, and check like the quality in different niches like coding, inference, science, and whatnot, like different categories to actually make a objectively right decision on the code quality, on the model quality per GPU, because that's for some reasons is dependent on that. And the last real big struggle was the software stack, because like I said, there are like some parts which are kinda the per se standard by now. So like Olama or VLLM, or it depends on what you actually want to do with it. But there is like no standardization. And by now, working 2.5 years with the SCS, I actually do like standardization, which I didn't do really before, but I now got the benefits of it. And having trouble with non-standardization over the past 1.5 years with all the AI stuff, I actually think that's a good thing. And as well here, we try to work with our team to make some more standards in this sector with the open source serving of models. Coming to the takeaways, GPUs are still expensive. It's getting worse every day, especially now with all the other hardware, which is more expensive and more expensive. And the biggest takeaway for us was that consumer GPUs are competitive, especially in the inference, which is like the normal like chatting, if you want. For those tasks is 100% a competitive version of data center GPUs, and for serving bigger models, which is the biggest concern many people have when talking about consumer grade GPUs, that they don't have enough VRAM to host like bigger models. There are solutions for that as well. You can combine multiple cards together and share their VRAM. That's even possible over the network to make even bigger clusters, which allows serving like really big models on consumer grade cards, which, to be honest, is not the same performance as if you put it like on the data center cards, which are way more, which have way more VRAM, so it's way easier. We did like a lot of calculations on that, like how many tokens per second do we get out of it, and all like the KPIs you have to measure on AI. And on the price per performance KPI, the consumer GPUs for classic inference mostly won. Like not in every circumstance, but in most of them, they actually won, which proved that we did early on the right decision and the right testing to go the way with the non-data center cards. But to be honest, as of right now, we do have data center cards as well, because like I said, in some niches you actually have to use it. Yeah, the same thing goes for the AI rigs. We decided very early that it's not suited for us, for our use case, to buy a complete AI rigs, especially because there are not much on the markets if you want to go with consumer grade cards, because of airflow and just the size of the cards. And so we decided early on to build the rigs ourselves, which has actually their own problems, and not only small ones, some bigger ones as well. the first chassis we built, there was a colleague going with a flex and cutting something out of the chassis to actually have place for all the GPUs inside and making the airflow work. But as of right now, like 1.5 years later, we have like a default set which we have now, which we don't have to use any flex or other things as well to destroy or manipulate the chassis. And we're pretty happy with that. As of now, we're doing, as of right now, everything is air cooled by now. Water cooling is the way to go for big GPU clusters, in my opinion, or in our opinion. But if you don't plan to actually do it in a big scale, airflow is totally fine in our opinion. And it's just like a matter of doing the calculations and setting up the environment right for it. Yeah, one takeaway was as well that talking about the SCS part of it, we have like 2 regions with SCS compatible clouds, all based on OpenStack, and we do want it to host everything of this AI business we did on our own platform for sure, and not building like a third one. So we tried out early on how the PCIe pass-through is working, and if like we get all the performance and the drive compatibility and whatnot. And as of now, we can say that the pass-through of OpenStack works like a charm in those cases. So that's actually a really good thing. And yeah, like I said before, data center GPUs are mandatory for some use cases, but definitely not for all. And AMD is an option, but also not always. And with the usage of like open source software plus our on top individual implementation, which we partly contributed back, not in every. I'm sorry. Not in every regards, but and not in every part, but we try to how do I say it, like push all the things we can push back, which is not like very individual for the customer, back to the open source community. Yeah, where are we now? Right now we can offer like 2 different parts of AI. One is like the most needed one for most. It's like a 100% OpenAI compatible API. Where we can serve as of around different open source models for specific use cases and general purpose. And the other thing is that we, like as I said early on, sometimes you have to like make some added value for the customer to for him to be able to make the decision, because then it's just like sometimes too comparable or just not the needed part. Is like a fully individual rack system, which we built on top of that, where customers can have like individual data enrichment and automatic scraping and gathering. The technical overview for how we built this design on top of the SCS is that we, like I said, doing the PCI pass-through on dedicated hypervisors. Those hypervisors are, as of right now, just dedicated for those GPUs, and we're using them for ourselves. So a customer, as of right now, cannot book VMs with GPUs and host the models themselves. That's a potential thing which we can just add, but we haven't had the need as of right now, because like the market is more demanding, on our opinion, on the solution itself, and not in the experience you have and all the things. So what we do is that we have, like I said, the hypervisor with GPUs and doing the PCI pass-through on an operating system. We have some shared ones, and we have like some dedicated ones as well, where we have like dedicated LLMs for a special customer, which he needed exactly that model, and we didn't see the purpose of it to actually make it generally available. So it's like a dedicated one for them. In the front, we have an LLM proxy where we do all the model routing. So all our models are not exposed directly to the internet. They're all inside OpenStack and just privately connected to our redundant LLM proxy, where we do all the model routing depending on like I said, it's 100% OpenAI compatible. So you can decide on the request, the customer or like the user can decide on the request which model he wants to use and uses the specific endpoint. We can support the normal, the old, like the chat completions endpoint, or also like all the new responses endpoints. And yeah, as you know that from OpenAI and all the other big ones. So every customer has the option to just like swap over from his setting, which he has now perhaps with OpenAI. With the API, can just swap over the endpoint to us and use the models we can serve for him. Our LLM proxy is responsible for also all the API keys. And the API keys have like special rights to which model they have access to and whatnot. And there is also all the billing, which we also can deliver by a token price, as the market standard is also. And we have tracing and monitoring for a deeper troubleshooting, which the customer can ask us to activate if he needs it, or we can activate that for actually dive into problems if we have some, to actually see the complete flow of the request from the customer. Especially that's especially needed for the customers which doing some like RAG or other pipeline stuff, where there are multiple models on the way until the response is sent to the customer. So it's very hard to replicate that. So we have their tracing and monitoring to see all this informations and at that. The LLM proxy also provides us with the possibility to offer custom LLM endpoints, which is then needed when, for example, a customer wants to have, special tools, which the LLM should call like own tools, which he wants to implement themselves or ask us to implement them. Then we can offer like special endpoints, which is just usable for them, for example. But in the end, it's just a pipeline and it goes to the right model as well. There's also features like load balancing in the proxy and failovers. If like one model fails for some reason, then we have also like backup models which take over the request and will handle the response. Perhaps not in the same quality, but at least there is a response and there is a working flow. Yeah, as I said before, using using consumer grade GPUs has some problems, but we or you can actually go and solve them. There is potential, and we do actually use that by now to serve bigger models. Our biggest model is like 300 gig of VRAM needed, and you can do that via parallelism over the GPUs itself on the single node, or we can make it even bigger and make it over the network as well. For sure, you need like a really, really fast network connection. We are doing 400 gigabits between the nodes to actually make that possible, because the network will most likely be the bottleneck here. As of right now, we don't see any issues. We're doing that for now close to 6 months. and having a lot of traffic on them. And from the experience, we can just say it works actually very good. And for price sensitive people, or if you actually want to make the same model, the consumer grade GPUs are definitely worth to look into. We're not doing any CPU inference, which like some competitors try to do, especially from the RAM perspective as well. There's potential solutions for like overspilling the VRAM into the normal RAM, which there are use cases for that, but we try to not do that. We do use quantizations of models if needed. That's especially for the real big models. It's a pretty standard way to like to pay some quality or speed or other parameters to actually make it work with less VRAM. But you have to keep an eye on that, because sometimes the quantizations are definitely way worse than the original model. And sometimes the quantizations are only like a few percentages worse. And in some specific use cases, I can say that as well, from our experience, smaller models can outperform bigger models in specific use cases. For example, in the RAG context, for example, when you do retrieval augmented generation, smaller models do work better than bigger models because they have less knowledge. They are more forced to use the RAG context. So the response quality is definitely better, but also that's a hard statement to just say. So I have to add, it's specific to specific to the use case you do, and it can be worse. But in our experience, if you do it right, the small models actually work better. We do have to write custom tokenizers and create custom pipelines for many of the use cases we do in the AI by now, because the standards which there are in the open source community are just too much general purpose, and they don't suit, or at least they didn't suit us. We're happy to talk about that and share those informations if needed or if wanted. Coming to our next steps, what we are looking into for the next 6 to 12 months. That's a little bit crazy because the AI market is so fast. So we are try to make like 3 or 6 month steps normally at max. But we try to make a better variety in model selection. As of right now, we have like 5 big models, or like 5 models which we normally serve, and like a few specific ones, and 1-2 dedicated ones. And as I said, like a little bit earlier, the software stack is not that perfect, to be honest. So we invested already a lot of time into making the serving a little bit more robust, especially in the context of not hosting it for yourself, like hosting it as a provider, as a solution where customers have SLAs and expectations. So that's a big part. And we want to make out of our architecture now, and we already on it, build like a reusable and sustainable framework, which we preferable make open source. But I guess some of you guys do already open source work, or perhaps have a project open source. I didn't know that. That's like a lot of work to make a project open source and make it right. So we are diving into that topic as well. And we're trying to enhance overall model quality. We are having 2 I don't know, I call it just AI engineers, which are working nonstop of trying to make customizations to the models, to tokenizers, and to all the loose parts inside this whole gear set to actually make the model quality better to perhaps reach at some point a real parity, because we don't lie to ourselves, and we make that pretty clear to every customer. We are not on the level of, for example, GPT-5. I guess we are like, I don't know, we make some tests, so I guess like 10% worse overall, perhaps 15%. We are on par with GPT-4. In our opinion, in our customers' opinion, they make tests as well all the time. So there is a big potential, and I want to emphasize this to all of you, to make AI in an open source context work in a near the same quality as the big ones. But as I said, not 100%, and that's really hard to do, especially as a small company. One of the big things we're working right now, and that will be definitely part of the reusable, sustainable framework, is this, I'd call it a single model interaction, like ChatGPT. So that's what I mean by this, is that you go onto the chat, just chat with our AI, and the AI pipeline itself decides, okay, do I need to think about it? So I send it to a thinking model. Does he want to create an image? So I send it to the image generation model, or I guess you get the idea. So that's a big thing we want to actually do. It's working kinda, but not perfectly. So we have still a lot of work to do here. And last but not least, one of the big steps I personally want to do, and that's one of the reasons we do this here today, is that we want to work with the SCS team on adding an AI layer to the whole ecosystem on top of the SCS, which will definitely enhance the overall idea of the SCS, and people will actually try it out and get it even, or find it even better to use it, because the infrastructure itself is only the baseline, as we all know, and then on top we need like additional features like the Kubernetes part, or like and potential AI part and whatnot. Yeah, coming to the one of the last things, I didn't want to just talk. I wanted to show you at least one or two things. I need to see if I can do that here. Perfect. So as you can see, that's like a standard web interface, as you all know. That's based on LibreChat. Perhaps some of you guys know that. And we implemented, like we have this model there is our flagship model, and we activated web search for that, or at least for that query. And I can show you that, for example. I did it yesterday, and I can ask it as well. So I asked, the first question was, what is the sovereign cloud stack? And I got like a pretty basic answer, which is potentially right, but I wanted to have like some more news, so I asked him about exactly that, and then I saw like all the web research which it does, and got all the information I need. I want to show you a little bit about the performance that we can deliver, because performance is one of the biggest things we our customers actually want, because they want like not a slow AI. They want to have it like really faster than they can read. So we try to always try to be on top of that. And I mean, you can just like ask the same question: what is the sovereign cloud stack, and who is the founder? And it actually tries to get together do the internet search as well. On the internet part, we try to be on the web search. We try to be sovereign as well. There, the stack below is there below we ask like a different search engines, but as of right now, we only ask European search engines. There's like a French one, and there is a Cosia, and like two others, and we try to use all of them. And that's below the framework, which does all the search in the search engines, is SERPA. Perhaps you guys know that. And yeah, that's a web search, which is pretty cool and pretty fast as well. Normal model quality is if I deactivate it, model performance is what is the open source business? Perhaps it doesn't need to be question the it doesn't need to question the web search, or actually I activated in the backend. But yeah, that's like the performance we have on this model. And now you see like the question which the model will send to the search engines to gather like all the information we need to make a pretty good answer in the end, which is reliable. Because the open source models always have the problem that they are not as new as the closed ones or the proprietary ones. You always have the problem of being a little bit late from the dates perspective, from the knowledge you can offer to the customers. So web search is actually one of the biggest features we had to add for all the customers because they want news from now and not from the past year. So yeah, coming to an end and going to the Q&A section. Lisa.